Assalamualaikum dear students, I hope you're all fine and in the best conditions of your health. Due to the current situation of the spread of this corona pandemic, so we have to continue our lectures in the form of online classes. So in connection with online classes, our today's lecture will be about introduction to bonding. Right, so in this context, the key concepts we will study will be about bonds. So we'll see what do we mean by a chemical bond, and then we'll see about Ionic bond and covalent bonds. So let's start with the bond. Right, the chemical bond is just a force of attraction between the two nuclei and between the nuclei and the valence electrons of neighboring atoms. The bond is just a force of attraction, it's nothing else, just a force that's holding the two atoms together. And this is the attraction between a nucleus and the valence electrons. Alright, so one nucleus of an atom attracts the valence electrons of the other atom, and the valence electrons of the other atom attracts the nucleus of the neighboring atom, right? So just remember that only the valence electrons are involved in bond formation, right? So valence electrons are the electrons that are present in the outermost shell of the electrons. So these are the outermost shell of atoms. Right, so electrons in the outermost shell of an atom, these are known as valence electrons, and always remember that it is the only valence electrons that are responsible for formation of a chemical bond. Right, so why a chemical bond is formed? That's important to answer, because chemical bond is formed because that results in overall decrease in potential energy of a system. Right, so what happens that when the potential energy of a system decreases, that the system become more stable, right? So atoms, if they stay alone, if they stay separated, they have very high potential energy, and because of this high energy they are unstable. So what happens that when they form a bond, their potential energy decreases. So decrease in potential energy is responsible for increase in stability. Right? So in short, we say that a bond is formed in order to increase the stability of the system. Right? So another justification is that atoms form bond in order to achieve the noble gas configuration. So it's a noble gas configuration. So noble gas are the members of group 8 of the periodic table. Right? So these gases were previously known as the inert gases. Why they were called inert gases? Because under normal conditions they don't react. Right? Scientists explore why these gases are not reacting. What is so special about them? So scientists found out that all of the noble gases or the inert gases, they had their valence shell complete. So there comes the generalization that atoms react in order to complete their outermost shell, right? So the atoms have the tendency to complete their outermost shell, because if they complete their outermost shell just like the noble gases, then they will become stable. And why they will become stable? Because by completing the outermost shell, their potential energy will decrease, right? So in general, you know that why bond is formed. So bond is formed because the bond formation results in decrease in potential energy and increase in stability. Right? So atom will form bond in any way. Either they share electrons, or they give electron, or they take electron, and the purpose is just to complete their outermost shell. Because once the outermost shell is completed, then the potential energy will decrease, and decreased potential energy will result in increased stability. Right, so sometimes always remember that atoms are not like ions. So ions are charged species, atoms are not charged species, atoms are electronically neutral. Right, so there is no charge on atoms at all. And always remember that while electrons share electrons or gain electrons or lose electrons, they do so in order to acquire a stable electronic configuration. Right? And what do we mean by stable electronic configuration? That means the configuration of noble gases. The electronic configuration just means the arrangement of electrons around the atom. Right, so configuration means arrangement. So electronic configuration means electronic arrangement, or the arrangement of electrons around an atom. So if there is a stable atom, for an atom to become stable, it is necessary that it acquires the electronic configuration of noble gases. In short, we say that atoms have the tendency to complete the outermost shell. Right, so basically there are three types of bonds which we normally consider, which are the Ionic Bond, Covalent Bond, and Coordinate Covalent Bond. So in this lecture, we will consider only about Ionic Bond and Covalent Bond. So let's just see about Ionic Bond. So Ionic Bond is bond that is formed by total transfer of one or more electrons from one atom to another. Right? So this is type of bonding in which electron is transferred in total. Right, so electron is lost from one atom and is gained by the other atom. Right, so this bond is formed, it's called the Ionic Bond. So when an atom forms an Ionic Bond, then as a result, the compound that's formed are called ionic compound. Right, so ionic compounds have characteristics that they form crystals. Right, so the ionic compounds form into crystals, and the crystals have repeating units. Right, so therefore we never write a formula for ionic compounds. Right, we always use the formula unit. So in case of inorganic chemistry, which you have studied in the previous semester, I suppose that you know about the formula unit. So formula unit has the atoms in their simplest ratio. Right, so ionic compounds always form the crystals, and the crystals have repeating units, and these repeating units are known as crystal lattice. Right, so you can never see a crystal lattice in case of a covalent compound, but it is characteristic of ionic compound that they form ionic compound with crystals, and the crystals are in the form of repeating units, which are known as the crystal lattice, and we always use formula unit, right, instead of molecular formula for ionic compounds. So ionic bonds are extremely stronger. So why these are extremely stronger? Because there is attraction between a positively charged ions. So attraction between a positive charge and a negative charge is very, very stronger. So since the ionic bond or any type of bond is just a force of attraction, so if a force of attraction is stronger, then the bond will also be strong. Right? So the attraction between positive charge and negative charge is very, very strong. That's why ionic bond is extremely strong. So how ionic bond is formed? So ionic bond is always formed when there is a reaction between a metal and there is a reaction between a non-metal. Right? So why we are taking a metal and a non-metal? Reason being that the metals are good losers of electrons. They can lose electron easily. While non-metals from group number 5, 6, 7, they tend to accept the electron very easily. Right, so that's the important thing you should know about ionic bond. The ionic bond is not formed between all types of elements. So it is necessary that ionic bond is formed between a metal and a non-metal. So why we are saying that it's formed between metal and non-metal? Because metals are very good losers of electrons. They can lose electron very easily. Right. So when a metal loses electrons, it forms a positively charged ion, which is known as a cation. And non-metals, they are very good in accepting the electrons, and specifically our focus is on non-metals of group number 6 and 7. These are the oxygen family and the halogen family. Right? So these non-metals, they are very electronegative, so they easily accept the electron and form negatively charged ions. So negatively charged ions are known as anion. So the attraction between this cation and this anion will result in formation of an ionic bond. So just for example, see, this is sodium and that's a chlorine. So sodium is a metal, so it can easily lose electron. So sodium has lost electron, it will form a positive charge here in a chlorine that will accept the electron which was lost by the sodium. So chlorine will form a negatively charged ion. So the attraction between positively charged ion and negatively charged ion will form an ionic compound, which is NaCl. Right? So let's briefly discuss about what are the properties of ionic compounds. So ionic compounds are also known as salts. Right? So ionic compounds Number one property, they are entirely composed of ions. So ionic compound has two components, a cation and an anion. So overall these are electronically neutral because the number of positive charge ions is always equal to the number of negative charge ions. So the positive charge and negative charge are equal, so therefore they cancel the effect of each other. So ionic compounds, although they are composed of ions, but they are electronically neutral. Third property, ionic compounds always form a crystal lattice, right? So crystal lattice has its own geometrical pattern, right? And the crystal lattice, in the crystal lattice we always express the crystal lattice in terms of their formula unit, right? So we never write a molecular formula for ionic compounds. Right, so ionic compounds form crystal lattice. Further, ionic compounds have very high melting points, right? So they are normally solid at room temperature. They are brittle and they are hard. So what do we mean by brittle thing? Brittle is a object, brittle is a thing that when it breaks, it shatters, right? So anything which shatters, then that's called a brittle, right? So it should be a solid object, but it should be an object that whenever that solid object breaks, that shatters, right? Just like a glass, so when a glass breaks, it shatters, right? So ionic compounds are brittle and they are hard. So they never conduct electricity in their solid state. They always conduct electricity when these are in liquid state or these are in molten state. Right, so what's special about in liquid state or in molten state? Because in liquid or state or in molten state, the ions are free to move. Right, so these three ions, these three positive and negative charge ions, since they're free to move, so therefore they conduct electricity. But in case of the solid state, so there is no free movement of the ions. So that's why the solid state doesn't conduct electricity, whereas the liquid or molten state conducts electricity. Also, the solution phase are good conductors of electricity, as mentioned earlier. So let's just take an example of formation of an ionic bond. So here we are considering formation of an ionic bond between potassium and a fluorine. So here we have a potassium. So potassium is a member of group 1 element, right? So group 1 elements are metals. They are known as alkali metals. Right, since it's a metal, it is very good in losing the electron, while on the other hand we have a fluorine, right? So fluorine is electronegative atom and it belongs to group number 7 of the periodic table. So it's a halogen basically. So if you just see the electronic configuration of fluorine, so it has 7 electrons in the outermost shell, right? It just requires 1 mole. So if it gets 1 electron, then in that case its outermost shell will be completed. Here we have potassium, so it's 1 electron in the outermost shell, and if this potassium loses 1 electron, then its inner to the penultimate shell, its inner to the valence shell will be complete, right? So the valence shell is the outermost shell. So here we have shown the electrons in the valence shell, and the shell inner to this valence shell are known as penultimate shell, right? So this potassium has a complete penultimate shell, but it has just 1 electron in the valence shell. So what the potassium wants to get rid of that electron in the valence shell. So if it loses this electron from the valence shell, its penultimate shell will become the outermost shell, right? And the penultimate shell will be complete. Therefore, the potassium wants to remove that electron. So potassium easily loses that electron, and it will form potassium positive ion, whereas this fluorine that will gain the electron which was lost by this potassium. So fluorine will form a negatively charged ion because it has got the extra electron, right? So this attraction between this cation and this anion will result in the formation of an ionic bond. So that was about ionic bond. Also let's consider about covalent bond. So covalent bond is between the molecules which are known as true molecules. So these covalent compounds are known as the true molecules. For example, covalent bond exists between the ammonia, NH3, it exists between the chlorine, which is the diatomic molecule, and it exists between water as well, right? So whenever there's a covalent bond, we consider the covalent compounds to be true molecules, right? So see what the covalent bond is. right? So in covalent bond, atoms still want to achieve a noble gas configuration, right? That means they have to complete the outermost shell, because by completing the outermost shell, they will have a decrease in potential energy, and the decrease in potential energy will lead to the stability. But they achieve the noble gas configuration through some other way. So in covalent bonding, neither of the two atoms lose electron or share electron, right? So the two atoms will form a bond, but both of these atoms, they will not lose or gain electrons, except what happens that they share the electron pair, right? So in covalent bonding, what's the difference between ionic bonding? So in ionic bonding, one atom is losing electron, other was getting that electron. But in covalent bonding, so there is no losing or gaining of electrons, it's just the sharing of electron, and the sharing of electrons is mutual, means the both atoms will contribute one electron, and the both atoms will share the electron pair, right? So how we can define a covalent bond? So covalent bond is the force of attraction due to sharing of electrons between the atoms, right? So the group of covalently bonded atoms will have no charge at all. So in ionic bond, there was a positive charge on the atom that lost the electrons, and there was a negative charge on the atom that gained the electron. But in case of covalent bond, there is no overall charge. So that's why the covalent compounds are called a molecule. Alright, so again we'll continue with covalent bond, and let's see that covalent bond is formed between which type of atoms, right? So as mentioned earlier, the covalent bond always involve the mutual sharing of electrons. Right, the covalent bond is always formed by mutual sharing of electron. Both of the atoms have to share electron. So which type of atoms form a covalent bond? So hydrogen atom forms a covalent bond, and in addition to this hydrogen atom, so the atoms in group number 4A, 5A, and 6A, and 7A, they also form covalent bonds between one another, right? So if you have any non-metal, the non-metals tend to form covalent bond with one another. So hydrogen also forms the covalent bond, right? So whenever you have a non-metal from group number 6A or 7A and a metal, we always get an ionic bond. But when you are trying for covalent bond, you have to go for atoms like hydrogen and atoms like group of 4A, 5A, 6A, and 7A. So these atoms together they form covalent bond, right? So covalent bond is of different types. The covalent bond can be single, it can be double, it can be triple, so depending on the number of electrons pair shared. So if just one electron pair is shared, the covalent bond will be considered as single covalent bond, right? And if two electrons are shared, then two electron pairs are shared, then that will be double covalent bond. And if three electron pairs are shared between two atoms, then in that case that will be a triple covalent bond, right? So it's important for you to remember that which type of atoms form a covalent bond, right? So let's say that why these atoms are forming a covalent bond, why not ionic bond? So let's consider this atom from group number 4A. So the elements from group 4A, they have outermost shell with 4 electrons. So it's not possible for this 4A to lose 4 electrons, right? Because it becomes difficult for an atom to lose 4 electrons, because by losing 4 electrons it get progressively positive charge, right? So with the increase in positive charge, say the nucleus will not allow the electrons to be lost easily. So when you have a positive charge, the attraction between this positive charge and the outermost electrons will increase, right? So because of this increased attraction, so this nucleus will not allow the removal of all 4 electrons. So 4A cannot lose 4 electrons. Similarly, 4A cannot gain 4 electrons as well, right? Because in that case it will get a 4 negative charge, and having a 4 negative charge, that's a very huge thing, because there will be repulsion between the new electrons and the original electrons of the atom, right? So the 4A will not form an ionic bond, because it can neither lose electron, it can neither gain electron. What it does the sharing, right? So it can share 4 electrons either with atoms like itself or the atoms of hydrogen, or it can form a covalent bond by sharing electrons with 5a, 6a or 7a atoms. Similarly, we have group number 5a. So 5a atoms, if you consider they have 5 electrons in the outermost shell, right? So they are missing 3 electrons. So if you say that they have to lose 5 electrons, that will be very, very difficult. So they can gain 3 electrons, but depends what is the thing they are reacting with. So if you are treating this 5a with a metal, they will form ionic bond. But if you are treating this 5a with some hydrogen, or with member of group 4a, or member of group 6a, or member group 7a, then among these elements, this 5a cannot lose electron, cannot gain electrons, because 6a will never give electron to 5a, right? So 6a also wants electrons. 5a cannot lose electron. 7a similarly, it cannot lose electron, it can only get electron. So all of these are not wanting to lose electrons. So what they do is that when these are together, so when you have a member 4a and 5a, they form a covalent bond. Similarly, when you have 4a and 6a, they will form covalent bond. When you have 4 or hydrogen, they'll form covalent bond itself. Similarly, so when these atoms are together, when you have atom of hydrogen, when you have atom of 4a, 5a, 6a or 7a, then when they are together, when they react together, they always form covalent bond. They never form ionic bond. So if you want to make an ionic bond, you need to have a metal with here, right? So let's consider the example of a single covalent bond. So we have 2 chlorine atom here. So this is a chlorine atom. So if you just see that it has 7 electrons, right? Just in circle. So these are the 6 electrons, and this electrons is the 7th one. So chlorine has 7 electrons. Similarly, this chlorine also has 7 electrons. So what they do is that they share the electrons. So you can see these 2 electrons. So one electron is from this chlorine and other is from this chlorine. So both of these electrons are now shared. So this is called the bonding pair, right? So in ionic bond, there's no bonding pair, right? So in covalent compounds, in covalent bond, there's a bonding pair. So this is the bonding pair of electrons. These are 2 electrons which are shared between these both of 2 atoms in this way. So this atom has 8 electrons. It has completed the outermost shell. Similarly, this chlorine also has achieved the outermost shell, which is complete. So that's become stable, and it has also become stable. So covalent bond that's formed by sharing 1 electron pair is called a single covalent bond, and it's denoted by a dash here. So we put a dash here. So single dash indicates this is single covalent bond. So we never make use of a dash in case of ionic compounds. So that's the difference between representation of an ionic compound and a covalent compound. So in ionic compound, you will never, and you can never place a dash, because a dash means these are the electrons which are being shared, right? So in ionic bond, there is no sharing of electrons, so you never use a dash here. Alright, so let's consider formation of a double covalent bond. So for that example, we are considering the use of 2 oxygen atoms. So this is oxygen. So oxygen is from group number 6 of the periodic table. So it has 6 electrons in the outermost shell. You say 1 electron here, 1 electron here, and these are the 2 unpaired electrons, and these are the 2 lone pair of electrons. So they don't participate in bonding normally. So this oxygen and this oxygen, so they will share this electron. So and this oxygen, they will also share another electron pair. So they are sharing 2 of the electron pairs, right? The covalent bond is formed by sharing of 2 electron pairs. This is called a double bond, right? The 2 bonding electrons pair we have. So one is being shared with that, and this is also a electron pair that's sharing. Say a bond which is formed by sharing of 2 electron pairs, that's called double covalent bond, and double covalent bond is indicated by double dash here. So in case of covalent compound, what is very important is that you should know that when you have a single bond and when you have a double bond, then the bond strength increases as the number of bonds between the 2 atoms increase. So if you have a single bond between 2 atoms, the bond strength will be weaker, but when you have a double bond between these 2 atoms, then the bond strength will be higher, right? So this is the double bond. So this double bond is stronger than a single bond, right? Similarly, if you can have 3 bonds between 2 atoms, then the triple bond will be more stronger than a double bond, and in terms the double bond will be more stronger than the single bond, right? So let's just compare the ionic bond and a covalent bond, right? So just for a summary, let's consider that ionic bonds are formed by transfer of electrons from a metal to a non-metal, while covalent compounds involve sharing of electrons between two nonmetals, right? Ionic compounds always form crystal lattice, while covalent compounds always form true molecules. Ionic compounds are always solid, while covalent compound can be solid, they can be liquid, or they can be gases. Ionic compounds have high melting point, while the covalent compound have comparatively lower melting points. Ionic compounds are water soluble, while covalent compounds are not usually water soluble. So lower molecular weight covalent compounds may be water soluble, but they are not usually water soluble. So ionic compounds are good conductor of electricity in the form of solution or in the form of liquid, while covalent compounds are not conductors of electricity. So this is so far the comparison between ionic bond and a covalent bond. Let's consider another concept which is very important in terms of covalent bond. That's bond polarity in covalent bond. So far we have discussed that the two atoms, they share electrons, and we have assumed so far that atoms share electrons almost equally, right? So when the two atoms are sharing electrons equally, so electronic density is present symmetrically between the two atoms, right? What do we mean by symmetrical electronic density? It means this atom has the same amount of electronic density as this atom, right? So such a bond in which the electrons are shared equally, such covalent bond is known as nonpolar covalent bond. It's a nonpolar covalent bond, so electrons are shared equally and the electronic density is symmetrical between the two atoms. And normally a covalent bond is formed, nonpolar covalent bond is formed between two identical atoms. So if the two atoms are same exactly, then in that case the covalent bond will be known as the nonpolar covalent bond. So suppose we are again saying this is a polar covalent bond, right? So in case of nonpolar covalent bond, we saw that electronic density is shared equally, right? But in case there is a polarity in covalent bond, then electrons are shared unequally. Still they are sharing, but the difference is that the electrons are shared unequally. So the electronic density is asymmetrical. Asymmetrical means it's not symmetrical, right? So one of the atoms has greater electronic density, so greater that loop is, it means electronic density is greater here, while in case of this loop is smaller, so it means electronic density is reduced here, right? So the atom that has greater electronic density, since electrons have a negative charge, so we say that this atom has greater electronic density, so we indicate that atom with partial negative sign. The partial negative sign indicates that there is higher electronic density, but partial means half. Since that's not a true negative charge, so we make use of this symbol, that's the partial sign, right? Partial sign indicates that bond is covalent, electrons are shared, but this atom is keeping the electrons towards itself more, right? So an atom that keeps the electronic density more towards itself, such an atom is said to be partial negative. And the atom that keeps the electronic density lesser towards itself, so this atom is unable to retain the electronic density. So atom which cannot keep the electronic density more towards itself, you can see that here the loop is very, very weaker, right? So this atom is said to be partial positive, so we say this atom is electronically rich because it has greater electronic density, and this atom is electronically deficient because it has reduced electronic density. But always remember, this is still a sharing. So since that's a mutual sharing, so that's a covalent bond, and a covalent bond in which there are poles, in which there is a partial positive charge and partial negative charge, such a covalent compound is known as polar covalent compound, right? Now, just for summary here. So here we have nonpolar compound. So here that's a nonpolar covalent compound, and nonpolar covalent compound is so that the atoms should be same, right? So if the atoms are same, the electronic density is shared equally, so the electronic density is symmetrical, and there is no pole. There is no partial positive charge or partial negative charge, right? Such covalent compound is known as non-polar covalent compound, while in case of covalent compound is such that an atom has greater electronic density towards itself, so it has pulled the electronic density towards itself, while this atom that has not pulled the electronic density towards itself to a greater extent. So this has reduced electronic density, it has gained electronic density to a greater extent, so this N will be partially negative, indicating that this is electronically rich, while this N will be partially positive, that's indicating that it's electronically deficient. So here you can see that here we have positive charge and here we have negative charge, and this not partial, that's full negative charge. So this is a positively charged cation, this negative charged anion, and they are feeling attraction for each other. So that's called ionic bond. Right? You can see just the electronic density. So the ionic bond and covalent bond only differ in the distribution of electronic density. So if the electronic density is distributed equally, such a covalent bond is known as polar, non-polar covalent bond, while if the electronic density gets split up, it gets separated completely. So one is positive, one is negative, that's called ionic bond. So you can see that polar bond, this polar bond is actually intermediate between a non-polar covalent bond and an ionic bond. Right? So if electronic density becomes symmetrical, so that will become non-polar covalent bond, and if the electronic density becomes completely separated from here, that will be ionic bond. So that's why we say that polar covalent bond is actually intermediate between an ionic bond and a pure covalent bond. Right? So in terms of polar bond, we always say that it has some ionic character. So why you can say the ionic character, because there is partial positive and partial negative charges. Right? So polar bond, since it has partial positive, partial negative charges, so that's why we say it has some ionic character. Right? So polar bond, polar covalent bond is always intermediate between non-polar bond and an ionic bond. So in the last slide we saw that there are three types of bonds, but there are two types of bonds, means a covalent bond, which is polar, which is non-polar. So what makes a bond polar? Right? What causes an atom to attract the electronic density toward itself? So the reason why a bond is polar is the electronegativity. Right? So what's electronegativity? Electronegativity is the ability of an atom to attract the shared pair of electrons to itself. Right? So I say again, it's the ability of an atom to attract the shared pair of electron to itself. So suppose we have two atoms here. So this atom, you can see this is attracting the electronic density toward itself. And this electronic density is basically the electron pairs that are shared. So ability of this atom to attract the shared pair of electrons to itself, this is called electronegativity. So normally, if you want to know which atom is electronegative, see the periodic table. So when you move left to right along the period, so on the right, what we have are the halogens, the oxygen family and the nitrogen family. So more you go towards the halogen side, the more electronegativity becomes. Right? So these are the electronegative atoms on the halogen side. So if an atom is electronegative, then that atom will tend to attract the electronic density toward itself more. Right? So higher the electronegative atom, higher the electronegativity of an atom, the more partial positive charge it will create. The more partial negative charge it will create. And lower the electronegativity of an atom, the more positive charge it will create. So just see, for example, so here we have chlorine here. So chlorine, since it's a halogen, it has greater tendency to attract the electronic pair. So you can see this is attracted electronic density to itself. So here is a greater loop. Right? And you can see there is a partial negative charge as well. So chlorine is good in attracting the shared pair of electrons to itself. But hydrogen cannot attract the electronic density. So hydrogen has reduced electronic density here. So hydrogen is here partially positive and chlorine is partially negative, but still this bond is covalent bond. So why this bond is covalent? Because still the electronic density is shared between these two atoms. So now if we have a bond between two atoms, right, and you want to know that which is polar and which is non-polar, you have to decide that whether the bond is polar, that's non-polar, or that's ionic. So what we do is we take a scale, right? And we make a scale and we say that in which range is the difference in electronegativity. So if the electronegativity between the two bonded atoms is 0, or it is between 0 and 0.3, right? In that case, the bond is said to be nonpolar, right? Let's say again that if you have to decide if a bond is polar or nonpolar, just see the electronegativity. So if the electronegativity difference between the two bonded atoms is between 0 and 0.3, then in that case the bond will be nonpolar covalent bond. While if the electronegativity difference is between 0.3 and 1.7, right, it's anywhere between these two, 0.3 and 1.7, then a bond is said to be polar covalent bond. Still that will be covalent, but that will be polar covalent. And if the electronegativity is 1.7 or higher, right, in that case that will be ionic bond. You see? So if you want to decide if a bond is polar or non-polar, just see the electronegativity difference. So if the electronegativity difference is between 0 and 0.3, then bond will be non-polar covalent. If the electronegativity difference is between 0.3 and 1.7, then bond will be polar covalent. And if the electronegativity difference is 1.7 or higher, then in that case the bond will be ionic. Now most bonds are considered to be a blend of ionic and covalent characteristics. We say there is some ionic character in covalent bond and there is some covalent character in ionic bond. So what's the difference? Just see here on this side. So here we are mentioning the percentage ionic character, right? So on this scale we are taking the electronegativity difference, and on this side we are taking the percentage ionic character. So if the electronegativity difference between the two bonded atoms is 0, then the percentage ionic character is also 0. So there is no ionic character when the bond is 100% covalent, right? So since there is 0% ionic character, it means that's 100% covalent bond. While if the electronegativity difference is 0.3, then in that case there is 5% ionic character in this covalent bond, right? You can see, just compare. If the electronegativity difference is 0, then there is 0% ionic character. It means the covalent character is 100%. This is 100% covalent compound. While if the electronegativity difference is 0.3, then in that case it has 5% ionic character. So you can see how much will be the covalent character. That will be 95%. So when the electronegativity difference is 1.7, then in that case the ionic character is 50%. So this bond is 50% covalent and 50% ionic. But when the electronegativity difference is 3.3 or higher, then this bond is 100% ionic. It means it is 0% covalent, right? So just by seeing this electronegativity difference scale, you can tell about what is the percentage ionic character in any of the two bonded atoms. So just suppose that we have electronegativity difference between 1.7, and I say what's the percentage ionic character in this bond. Just say if the electronegativity difference is 1.7, you may say, so that's 50% ionic character, and the other 50% will be covalent character, right? So that's all for today's lecture, and here's a quiz for you. So you have to solve that quiz. So you are given with 3 type of bonds. So this is a bond between boron and carbon. So you have carbon bond between carbon and nitrogen, and boron and silicon. So I've given the electronegativities for these two atoms, all of these atoms. So you have to tell which of these will be least polar, right? So you have you have to answer that question as well. So secondly, you have to differentiate between the electronegativity. So I've explained the electronegativity in this section, and you have to differentiate between the electronegativity and the electron affinity. So what's the difference between two? And finally, you have to answer why the elements of group 1A cannot form a covalent bond with the elements of group 7A. So you have to give a logical answer for that. Just understand the question and give an illogical answer, that why don't you think that elements of group 1A cannot form a covalent bond with the elements of group 7A. Alright, so that's all for today. Thank you.